When we are calibrating the machines that we use in science labs, we like our machines to be accurate and we like them to be precise. So, what is the difference between accuracy and precision? In the first figure, somebody threw 4 darts and all the darts hit the bullseye, the target. As a result, we say the 4 darts are accurate and they are precise, because accuracy refers to how close our measurements are in agreement with the true value or the accepted value. In this context, the bullseye is the target, that is the true value. And the 4 darts, they hit the bullseye. On the other hand, precision is a measure of how close individual measurements are in agreement with one another. Again, for this first structure, all the darts are in agreement with one another. But let us take a look at this second figure. In this figure, all the darts missed the target. However, they are all in agreement. You see a cluster of them in just one region. This is what we say is precise, because they are in agreement with one another. However, they are not accurate. They missed the target. We do not want to have that type of issues in chemistry lab, where we make measurements and they all will agree with one another, but they will be far off from the true value. In this third figure, the darts are all in the bull's eye. However, they are like all over the place within the bull's eye. So they are said to be imprecise, but because they all hit the target, they are said to be accurate. So they are accurate, but imprecise. In the last figure here, as you can see, all the darts are all over the place and they did not hit the bullseye. So they are not accurate and they are not in agreement with one another. They are not precise. So not accurate and not precise. That is the worst that we can get in a lab. Let us take a look at some data to understand the difference between accuracy and precision. 3 chemistry students measured the mass and volume of a piece of silver to determine its density. The actual density of silver is 10.49 gram per milliliter. The 3 students are David, Hamed, and Anjali. The 3 trials of David, after they have been averaged, they come out to 10.48 gram per milliliter. The 3 trials of Ahmed, they come out to 10.25 gram per milliliter, while the three values of Anjali, they come out to 10.58 gram per milliliter. Simply looking at those averages, we can immediately see that David's value are accurate. They are very close to the true value, to the actual value. But are they precise? Let us examine all the data. You will see that Ahmed's values are very much in agreement with one another, while David's value not completely in agreement. So the most precise of all the measurements here are Ahmed's measurements, while Anjali, the data obtained by Anjali are neither precise nor accurate. So you can see a very good example of how we compare accuracy and precision in the lab. But instead of eyeballing them like we just did, in the lab, the easiest way we determine precision is by determining standard deviation. A statistical analysis will be done and we will determine the standard deviation. While the best way to determine the accuracy of a set of measurements is to determine the percent error.